Hello friends, in today's question, in an LCR circuit as shown below, both switches are open initially. Now switch S1 is closed and S2 is open. Q is the charge on the capacitor and tau is equal to RC is the capacitance time constant. Then which of the following statement is correct? So we are given this circuit and here we have applied voltage V, two switches S1 and S2. So initially both switches are open and we have connected resistance in series with capacitance and we have inductor which is in parallel with these two combination. So initially both S1 and S2 are open. So the circuit, none of the circuit with respect to that capacitor as well as inductor will be complete. So there will be no energy stored in the inductor and there will be no charge on the capacitor. And as soon as the switch S1 is closed, the capacitor is going to charge through the resistance, whereas still the S2 is still open. So therefore there is no participation of the inductor in the entire circuit. And basically we are going to find out what will be the equation of the capacitor. Okay. So we start with the given options given to us, that in the first part it says that S1 is closed and S1 is closed and S2 is open. So under this condition, we can say that the circuit of R and capacitor C will be now in series. So therefore we can say from here that the circuit consists of resistor R and capacitor in series. The circuit consists of resistance R and capacitor C in series. Consists of resistor R and capacitor C in series. Secondly, we can also say that capacitor C is going to charge through resistor R. Capacitor C starts charging through the resistor R. And therefore the charge Q on the capacitor at any time t can be represented as by the equation. So we can say the charge Q on the capacitor at any time t is given by, and the equation is Q of t is equal to Q max, that's the maximum charge 1 minus e raised power minus t upon tau, where tau is our time constant, and the maximum charge Q max is our maximum charge on the we can say maximum charge the capacitor can hold. Maximum charge the capacitor can hold, and which can be also given as C multiplied by V, and tau is the time constant of the circuit, which is equal to product of resistance multiplied by capacitance. And we have to suppose to find out the capacitor of the charge when this tau is, or we can say when the t is equal to 2 tau. So we say charge on the capacitor at t is equal to 2 tau. So we simply substitute this value of tau. Let us suppose this is our equation number 1. You can say from equation 1 we get Q of 2 tau will be equal to Q max 1 minus e raised power minus 2 tau upon tau. Tau and tau cancels out. So we get charge at 2 tau will be equal to Q max 1 minus e raised power minus 2. And we can also solve it further if required, because in the question it is not required as such. So from here we can say that the option number C is the correct option. From here we can say option C is correct. But we can also solve it further. We can say that our Q2 tau will be equal to Q max, and we can solve this particular part 1 minus e raised power minus 2, and this comes close to as 0.865. So from here we can make one important conclusion also. So we can say that at t is equal to 2 tau, the charge on the capacitor is close to 86.5% of its maximum value. The maximum value is represented as Q max. And we can also find out the current in the circuit. So we can say current in the circuit at t is equal to 2 tau, and the charging current, you can say the current during charging if it is given as I of t, this will be equal to V upon R and e raised power minus t upon tau. And here now we substitute value of t is equal to 2 tau. You can say at t is equal to 2 tau we get I of 2 tau, which will be equal to V upon R, and this will be giving us e raised to power minus 2. And once again we can write this as V upon R multiplied by 0.135. So we can say that the value of the current at t is equal to t tau, 2 tau, sorry, you can say the value of current at t is equal to 2 tau is 13.5% of its initial value, and the initial value of the current will be given by V upon R. So we can also find out the amount of the charge with respect to the maximum value and the current at this particular instant of t is equal to 2 tau with respect to the initial value of the current. So this completes the question. Thank you.